So this video is week 2 and our third meeting where we're dealing with adding and subtracting integers. So we're going to look at all the rules that apply to that. We're going to look at a lot of patterns and kind of glean some reasoning of how we can add and subtract integers with number lines and patterns, and hopefully get a better idea of how these work together. Extremely important when you start working with equations. Sign operations are typically the number one error when you're solving an equation. So part of that, to begin, is recognizing when you have a zero pair. Okay, -3 plus 3, you have a number added to its opposite, and you're going to get 0 when that happens. So if you're looking at using counters, so I've got 3 positives and 3 negatives, so that would go to 0, that would go to 0, and that would equal 0. So we're going to use that idea when we start looking at how we can use counters to add and subtract for the modeling purpose. All right, so let's think about a number line first. Let's model all of these with the number line. So if I've got, I'm going to start with 0, and then I want to compute this. So 4 plus a -3. So what you would do is move to the right 4. So you'll see this movement like this to get to 4, but then I've got to come back to the left 3. 1, 2, 3, and then you see where you end up. And you're going to end up at 1. So 1 would be your answer. All right, let's look at the second one. -5 plus a -6. So if I start with 0, and let's do this for this purpose since I know where this is going. So this will be 0, so -1, 2, -3, -4, -5. So I'm moving to the left -5, and then I want to move to the left 6 more. So there's 5, 6, 7, 8, 9, 10, 11. So I end up at -11, but I'm continuing to move to the left. So I start at 0, I move left 5, and then I move 6 more to the left. Notice where I end up? That's your answer. So let's look at number 3 and number 4. So I start at 0, and I move to the left 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I move to the left 10. But then I've got to turn around and move back to the right 8. So 1, 2, 3, 4, 5, 6, 7, 8. Notice where you're going to stop. You're going to stop here at -2. And so -10 plus 8 would be -2. And then let's look at this one here. So -3 plus 2. On the number line, I can get my line straight. So I'm going to start at 0, and I'm going to move to the left 1, 2, to the left 3. So I move to the left 3, and then I'm going to come back. Just kind of show that direction there. And then I'm going to come back 1, 2. And notice where you end up. You're going to end up at -1. So -3 plus 2, you end up at -1. Okay, and then let's look at these last 2. So if I'm at 0 and I move to the left 4, -1, -2, -3, -4. And so I'll move to the left 4, And then I'm going to move to the left 4 more. 1, 2, 3, 4. Notice I'm going to end up at -8. So that's going to be my answer. So I started at 0, I moved left 4, I moved left 4 more, which would be a total of -8. And then the final example, we'll start at 0. And I'm going to move to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to turn around and move to the left 5. 1, 2, 3, 4, 5. And notice where you stop. And you would stop at -3. So the number line approach just allows you to kind of think through your movement, especially with adding, and wherever you end up is your answer. All right, so if we look at some patterns, and I'm just going to kind of write off to the side here the answers. So I got 3 plus 3 is 6, 3 plus 2 is 5, 3 plus 1 is 4, 3. So notice that the 3 is, of course, 3 is staying constant, and I'm changing the value of this number. So 6, 5, 4, 3. The way the pattern is going, this has to be 2, but notice it's 3 plus a -1. So you can use the number line approach. You start at 0, you move to the right 3, you move back to the left 1, you'll end up at 2. 3 plus -2, that has to be 1. And then there's your 0 pair. So then we've established the 0 pair, and then I'm going to keep the right hand column constant and then change this one. So there's my 0, and then I'm going to continue to decrease. Notice that there's more negatives, 1 plus a -3, so you move to the, start at 0, looking at this one, move to the right 1, then you move to the left 3, you're at -2. Start at 0, move to the left 3. Start at 0, move to the left 1, and then 3 more. So you see our patterns are making sense of what your answer should be. So when you get to this point, look at 5 and 6. You actually had more positives than you had negatives. And your answer was positive. When you had the same number of positives and the same number of negatives, you had a 0. And then here you've got a positive, on this one right here, 2 plus -3, you've got more negatives than you do positives. And so with more negatives than positives, your answer was negative. And then when they were both negative, from right here on, they were both negative, your answer was also negative. So now we look at different adding rules. So things that you can think about. Okay, we've obviously looked at patterns. Like we looked in this slide, we saw how numbers reacted, we looked at the patterns, we looked at the results. What happens if we kept a number constant, changed the other add-in, and then kept one add-in negative and changed the other one. So we saw results, okay? So this idea, really 2 ideas to think about, okay? When you're adding, if the signs are the same, then you get to add those numbers together and keep the sign of both. So for this one right here, you would ask, what's a -3 and a -3? Are the signs the same? Yes. So you would add those together, 3 plus 3, you get 6, and you would keep the sign of both. And of course that works if you had a 6 plus 6, they're both positive. So you'd add those together and keep the sign of both. This one's not the issue. It's the ones where either you have 1 negative or 2 negatives where we're going to have to think about how that result works. So what if the signs are different? If the signs are different, and you look at it, -6 plus 2, and you see, okay, those signs are different. So what you're going to do is you're just going to subtract those numbers. 6 take away 2, you're going to get 4. Then you look at the largest absolute value. So what's the absolute value of 2? 2. What's the absolute value of -6? 6. this had the larger absolute value. Look at the sign. The sign has to be negative. Okay, look at C. Are the signs the same? No, they're different. So let's subtract. So 5 minus 3, you get 2. Now, is the answer going to be positive or negative? Absolute value of negative 3 is 3. Absolute value of 5 is 5. That had the higher absolute value. The answer would be positive 2. So if you got two positives, of course that answer is going to be positive. If you have a positive plus a negative, it's not always a positive, it's not always a negative. It depends. For instance, right here, this is an example of where they're both different. So if the signs are different, well, one produced a negative and one produced a positive. So if you look here, you get 5 plus a negative 6. If you were thinking of the counters, you actually have 1, 2, 3, 4, 5 positives, 1, 2, 3, 4, 5, 6 negatives. You actually have more negatives. So all these zero pairs would disappear, leaving you with one negative. You can also think of it as I'm starting at 0, I move to the right 5, and then I move back to the left 6. I end up at negative 1. And then our last slide talked about if they're different, you can subtract. 6 minus 5 is 1. Which one had the largest absolute value? That absolute value is 6. It's larger than the absolute value of 5. The sign with the negative 6 is negative. The answer has to be negative. And then finally, you've got what happens when you have two negatives. Well, two negatives added together is going to be another negative. So that's what adding integers. So just to run through just a couple more examples here. So let's say I have negative 10 plus negative 3. And I would say, what about the signs? Well, the signs are the same. So let's add those together. I'm going to get 13 and keep the sign of both. So it'd be negative 13. And so then I could also think number line if I need to. I'm starting at 0 and I'm going to move to the left 10. And then I'm going to move to the left 3 more. And so I should end up at negative 13. Another one, what if I had 8 plus a negative 12? And I would ask, well, are the signs the same? And this would be no, they're different. So I actually get to subtract these two. 12 minus 8 is 4. And then I'm looking at what has the largest absolute value. Absolute value of 8 is 8. Absolute value of negative 12 is 12. This one's larger. This one has a sign of negative. So therefore the answer is negative 4. If I'm thinking number line, I would start at 0 and I would move to the right 8. So, and then I would turn and move to the left 12. Well, there's 8, and then a few more puts me into the negative, which would put me at negative 4. And then I could have it to where I have 12 plus negative 7. I would ask, are the signs the same? No. So we can subtract. So 12, let me rewrite that. So we'd have 12 take away 7, which is 5. What's the absolute value of 12? And that's 12. What's the absolute value of negative 7? That's 7. This one is the largest absolute value. It has a positive, so the answer is positive 5. If I want to think number line, I can start at 0, and I can move to the right 12, and then I'm going to move back to the left 7. And so I should end up at positive 5. Remember, you have your practice links where you can get your practice problems, and you can also get practice, you can get your video. It'll take you to Khan Academy or Virtual Nerd. Those are different examples and different web links that'll take you to different practice. So then the next one we'll look at is when we're subtracting integers. So we want to look at patterns and our rules. And so here we got the temperature in Bella Vista is 32 degrees at 6 a.m. and it rises 15 degrees by noon, but then it's going to fall 50 degrees. So we want to know, well, what's the final temperature? Okay, so we can think about it as 30, order of operations. 32 plus 15, you're going to get 47. It's going to get up to 47, but then it's going to drop 50. So at some point, our final temperature would be 3 below. Okay, another way we could write that is 32 plus 15 plus a negative 50. This is where that additive inverse is coming in. If I put a parenthesis around 50, notice I'm subtracting 50, or I'm adding a negative 50, or I'm adding the inverse of 50. If I'm going to change it from subtraction, I would have to use the additive inverse, where I add the inverse of positive 50, which is negative 50. So this would be 47 plus a negative 50, and you would ask yourself, well, are the signs the same? No. So we can subtract 50, take away 47 would be 3. Sign of the larger absolute value. What's the absolute value of 47? 47. What's the absolute value of negative 50? 50. This is the larger absolute value, and it has a negative. Another one of context is elevation. So the record, when we're talking about drilling underwater, so we are at negative 7,718 feet, and that was a record in 2000. So in 2015, we're just going deeper, that's all. So that just means that we're subtracting more feet as we're going deeper, or we can think of it as, well, we dug 7,718 feet, and we're going to add a negative 2,693 feet more into the negative. So, this picture of, well, you're drilling to your depth, but then you're going to drill some more, okay? So we've drilled 7,718 feet in a direction that's negative in regard to sea level. And so what we did is we drilled 2,693 feet more into the negative. So that just means that when you're adding this up, you could look, well, they're both negative. So are the signs the same? Yes. And when the signs are the same, you just add those together, and you'll get your total depth. All right, so let's look at some subtraction problems with patterns. So 4 minus 4, I'm going to get 0. 4 minus 3, 1. 4 minus 2 is 2. 4 minus 1 is 3. 4 minus 4 is... So notice our numbers are going up. Well, this next one is 4 take away a negative 1. I've been taking away 4, 3, 2, 1, 0. Now I'm taking away a negative. So you think about what has to come next. It has to be a positive. This has to be a positive 6 following these. So with a counter model, when you're modeling with your two color counters, you can think, well, I've got positive 4, and I need to take away a negative, but I don't have any negatives to take away. So what we'll end up doing is adding a 0 pair to this set, because this is equal to 0. So 0 plus the 4 doesn't change the problem. And now I'm allowed to take away that negative 1 and see that I'm left with 4 plus 1 is 5, which models here. So when you see subtract a negative, you are really adding a positive amount to the group. So this 4 take away negative 2 is going to become 4 plus 2, or 6. So when I see subtract a negative, I just know that I can rewrite that as an addition problem. And so look at this 4 take away 4? Well, if I model it with the counters, I've got 4 positives, and I need to take away 4 negatives. Well, I don't have 4 negatives to take away, so I'm going to add 4 0 pairs. And so now I can take away those 4 negatives, and it leaves me with the 4 positives here plus the 4 positive here. So I have now had 4, but I am now adding 4 more. So this is 4 plus 4, or has to be 8. So here we've got 4, subtract the negative, so that'd be 4 plus 4, so that's going to be 8. And this is going to be 7, and this will be 6, and this will be 5, and this will be 4. And now you got a negative 1, subtract a negative 4. So if I look at the counters there, I've got a negative 1, and I need to take away 4 more. Well, I don't have 4 to take away, but I do have 1. So what I'm going to do is just add 3 more 0 pairs. So that would allow me to take away these 3 and that one. And so they're all gone. And that's going to leave me with 3 positives. So if you simplify this, you would have negative 1 plus 4. Are the signs the same? No. So you can subtract 4 minus 1 is 3. Keep the sign of the larger absolute value, which would be that one. Again, continue with some patterns. So 6 minus 4, that's 2, 1, 0, and then 3 minus 4. So based on the patterns, that has to be negative 1. So when you have a positive amount and you're taking away more than what you have, you're going to be in the negative. It'd be like having $3 and spending 4. Well, now you're in the hole $1. This would be negative 2. You have $1, you spend 4, you're in the negative 3. You have nothing, you spend 4, you're negative 4. And then this just continues to be negative 5, negative 6. So you notice that you're just going more and more into the negative. But all of these, here's your 0 right here. So all of these from here to here can all be written as adding a negative 4. So 2 minus 4 would be the same as 2 plus a negative 4. So I am rewriting the subtraction as addition if I need to. And are the signs the same? No. So we would say 4 take away 2 is 2. Absolute value of 2 is 2. Absolute value negative 4 is 4. That's the largest absolute value, and it has a negative. So again, subtraction can be written as an addition problem using the additive inverse, and that's more of a if you see the example of 8 minus 3, being able to rewrite that as 8 plus a negative 3. And then are the signs the same? No. So 8 minus 3 is 5, which has the largest absolute value, 8 or negative 3. And it's 8, and it's positive, so the answer has to be positive. So 18 minus 6 can be written as 18 plus a negative 6. And you can think number line, you can think counters, you can think, well, they're not the same sign, so I'm going to subtract and keep the largest absolute value. These are some different ways you can look at subtraction, where 18 is the larger number, so the minuend is larger than the subtrahend. So 18 minus 6, well, that's going to end up being a positive 12. 18 take away a negative. Well, the 18 is larger than negative 6, and you're taking away negative 6, so that would be 24. Notice that results in a larger positive. Here you've got negative 18, subtract a negative 6. So you've got a smaller number taking away a larger number. So this subtract the negative is going to become positive. So that would be negative 12 as an answer. And then negative 18, take away a positive amount, would also result in negative 18 plus a negative. So that's going to put you farther into the negative. So those are some examples with adding and subtracting positive and negative numbers. And I hope that helps. You've got the video. Of course, you can rewind it and review what you need to. But these are two fundamental items that need to be really solid, because we're not going to use a calculator for the first part of the course. And then when you're solving equations, you need to be real careful with how the numbers react when we're using inverse operations, understand how additive inverse works when you're solving, and so forth.